Hello guys, for this simulation I have created two galaxies. Let me just zoom out to show you what these galaxies consist of. So I'm just going to activate my zoom out function. So you can see from good distance, all you can see is those galaxies are no more than a single dot on the screen, which is again very fascinating because they're massive structures. If I click on them, you will see in a single point I have been able to select 8,487 objects. Those are either black holes, stars, or planets. And I can see the masses, the position, velocity, acceleration of each and every object here. I can sort them with mass or velocity to see which one has highest mass, largest mass, and highest velocity. So let me escape that and lock onto one of the objects there. Let me say what I've locked onto. So I have just locked onto galaxy 1 black hole. And what we are going to do is going to go near that black hole, take a flight path that will take us nearer to that black hole. So let's go near it. So now we are flying towards it. And let's stop here. And we'll just take a circle around the black hole, which has in our view both the galaxies together. As you would notice that I've created these two galaxies quite close to each other because I was very much interested in seeing the interaction they will have. As you can see, this simulation has been now running for 22 years and 4 months and 10 days. And as you would notice that very few of the stars, in fact, I can just see here, let me just pause this one. I can just see one star here. As you can see, this is for the galaxy 0 black hole star 73. I just thought, it will be better to name it this way. And you can see just one star has escaped the galaxy, and there are few planets. And the reason behind it, when I was creating these objects in the galaxy, so all these stars in the galaxy and all the planets around those stars, I have given them almost perfect velocity so that they keep their orbit. So very few of them have actually escaped it. There's one more thing to notice here, and let me show that to you. Out of 8,654 randomly created stars and planets, most of them have survived, very few of them have collided. And the reason behind that is because most of the objects had very, um, well, they had almost perfect speed to keep in their orbits, right? So you can see that most of them have maintained their orbit and they haven't collided with each other, which is a very good thing that I wanted to test. Yeah. So now let's go closer to the black hole. So now I am going closer and closer to the black hole at the center of this galaxy. No, okay, so let's stop there now. And let's take a circle around this black hole, so which will give us the view of the galaxy from inside. Yeah, so how this will look like. So let's just admire the view of it from the center of the galaxy. We are looking outwards towards all the stars and the planets. And now you can see from inside this galaxy, we are able to view the other galaxy, which looks like a beautiful sphere from here. Now, if you look at all these other dots, let me just pause the circular flight. So all these dots that you see, so what I have done here is created lots of stars, and around those stars, you've got planets, right? All these stars have been created randomly, and all these planets around those stars have been created randomly. The only thing that is not random is their velocity around these stars and the velocity of these stars around the black hole. so that they can maintain their orbit. Because in this simulation, I wanted to maintain the order and I did not want to create chaos, right? So if I go to, let's say, let's point to one of these stars here. If I right click on it, I'll be able to center on that star. And now we are going to fly towards that star and let's see what's happening there. So let's fly to that star. We are flying very fast. Now let's stop here for the moment and let's take a circle around that star so that we have the rest of the galaxy in our view and the other galaxy in our view as well, because that will just make the view very beautiful. So let's do that. Okay, I'm just expecting. Oh, yes, we have got that other galaxy in the view. And let's stop there. And now we are going to fly the rest of the distance to the star, having this view in front of us, right? So let's go to that star. And you can see we are flying really fast. And we are going to the star now. But as you would notice that we are flying really fast and we are going to the star, and the star is coming closer and closer to us, but the view of that galaxy has hardly changed. And the view of these other stars inside this galaxy, they're hardly moving. The reason behind that is they are really, really far away. So even though I'm flying at a great speed towards this star, the view of the other stars and the galaxy outside this galaxy we are in right now is hardly changing, right? So let's take a circle around this star and look at all the other stars and planets in this galaxy and the other galaxy as well. And again, I just love it. It's breathtaking. Let's have a look at it. Okay. So now we are looking away from the other galaxy, so you can see, and probably this star is at the edge of this galaxy, so we hardly see anything there. So hopefully we are going to get a denser view of this galaxy in a moment. So now you can see the number of stars and number of planets in our view have increased. That's because we are looking in a different direction now. And now we are back to the view where we were able to see the other galaxy in our view. So let's stop here. And now we are going to again zoom out. And as we are zooming out, you'll see that the view of the other galaxy is not changing much at all. And the view of these stars in this galaxy won't change at all. And that's because of the astronomical distance we maintain with those objects, right? So I'm going to zoom out, actually fly away from this star. Now zoom in again, and you'll see that probably this is the star we are trying to zoom in onto, and this is the star, and this is one of the planets of the same star. So let's go on to that particular planet. Yeah, let's circle around it so that we can isolate the star of this planet into this view. So if I click on this planet again, you will see this is planet number 5 of the star 334. So if I click on this star, and let's see what is the star number of this one. So yes, that's in fact star number 334, and this is the planet of that star. So how about this particular planet? So let's click on that, and this is planet number 1 of the star 334. So let's zoom on to this one. Let's bring this in our locked view, and let's fly to this particular planet, and let's see how the view is from that planet. Yeah. So we are just going to start our journey to that planet. As you can see, the star has just zoomed past us and we are reaching that planet. And as you'd notice that there's nothing moving in this, even though we are flying really fast, in this view, there's nothing moving at all. And that is because all the other stars and the planet and that galaxy on our right hand side is really, really far away. They are hardly moving, but we are flying really fast. Let's just take a circle around this planet and see how the view is from this planet looking onto the other stars in this galaxy and the other galaxy itself. Let's just admire this view. Okay. For the sake of this particular fly past and navigation through the galaxies, I have paused the simulation itself for the moment. That's I have done that because I wanted a very steady uh, frame rate for this particular video. So let me stop circling, or actually circle in the other direction, so that we have the other galaxy in our view. So now, as you would see, um, we are on a planet looking at all the other stars in our own galaxy, and we are able to view the planets around those stars as well. Well, in reality, actually, you wouldn't see the planets, but for this simulation, because planets have been rendered in at least 1 pixel. You can see the stars themselves are visible as one single pixel. So planets, of course, won't be visible at all. But just for this particular simulation, what I have done is, if any object takes space of less than 1 pixel, we show at least 1 pixel so that we can see them in the view. So this gives us an idea of how insignificant we are when we are living on a single planet, and how enormous the universe is. Um, for the simulation, we can drive ourselves at the speed of, let's say, 50,000 kilometers per second. But still, that's that's a very high speed, by the way. But that's that's the speed that takes years to travel to other galaxy. Yeah, in the simulation time frame. So let's zoom out of this particular planet now. You can see again, nothing is moving at all. Only when we start traveling at a very, very high speed, we'll see some movement of the other stars and trying to get out of this galaxy, and probably see a zoomed out view of the two galaxies together. So that's all I intended to show you for this particular video. Um, I would continue the simulation. It has already been running for approximately 10 hours, and we have reached, in simulation time frame, we are at 22 years and 4 months and 19 days right now. Most of the objects have survived. I'll continue the simulation for, let's say, another 10 hours or so, and see how it progresses. Have the stars escape the galaxy? Have the planets escape the stars? We'll get a view. And if I find anything interesting, I'll make another video of that, and probably post it. Well, thank you so much for watching, and please leave your comments in the comment section below. Um, if you find anything exciting, if you'd like me to cover any other simulation as part of this series. Thank you and goodbye.